All right, let's just jump right in. Welcome to today's Explainer, where we're demystifying the literal backbone of modern manufacturing, welding robots. If you've ever looked at a sleek new car, or maybe a towering skyscraper, or a massive cargo ship, and thought, how in the world is that held together so flawlessly? Well, the answer is increasingly found in these robotic arms just humming away on factory floors. Today, we're going to break down exactly how these machines work, piece by piece, and really show you why they are, without a doubt, the future. So, to kick things off, why are welding robots so absolutely essential in modern factories? Well, just think about the sheer speed of today's industrial world. We aren't just building one car a day anymore, right? We're building thousands. And to meet that relentless demand without sacrificing even an ounce of quality, factories had to evolve. They desperately needed a solution that doesn't need sleep, doesn't get distracted, and can perform the exact same highly complex task thousands of times in a row with zero deviation. Here's our quick roadmap for today. We'll be covering 1. Intro to welding robots, 2. Key components and types, 3. Industrial robot applications, 4. Jobs and career, and finally, 5. DEVI automation solutions. Let's get to it. Section 1. Intro to welding robots, automating the spark. So at its most basic level, a welding robot takes the highly skilled act of joining metals and completely automates it. And there is a really stark contrast between manual and robotic welding. Don't get me wrong, manual welding is an incredible skill, but we humans have physical limits. We get tired, our hands can shake, and we're vulnerable to electric arcs that can literally reach temperatures upwards of 10,000 degrees Fahrenheit. No, thank you. Robot welding, on the other hand, just shatters those limits. A robot provides relentless speed, microscopic precision, and safely navigates extreme, toxic environments 24/7. And it does it all without ever needing a coffee break. Moving on to Section 2, Key Components and Types, the anatomy of a robot. To truly understand these machines, it actually helps to think of them like a mechanical human body. The robot arm is exactly what it sounds like. It's the physical arm doing the heavy lifting. The robot controller is basically the brain processing all the commands, while the teach pendant is how we communicate with that brain. Then you've got servo motors acting as the muscles, providing incredibly precise, smooth movement. The welding torch and power source make up the actual tool creating the spark, and the sensors and vision system act as the robot's eyes and sense of touch. And finally, the safety fence ensures that human workers stay safely out of harm's way. Now, of course, not every factory needs the exact same tool, right? Spot welding, for example, is heavily used in automotive assembly to join sheet metal in literal fractions of a second. Laser welding, that's for extreme pinpoint precision, sometimes joining metals at a microscopic level. And then you have TIG and MIG robots for your various arc welding needs. Really, the choice depends entirely on the material being joined and the specific manufacturing mission at hand. So how do all these separate parts actually work together? Well, let's walk through the basic working principle. Step 1. It all starts with a human programming the exact path and parameters using that teach pendant we mentioned. Step 2. The positioner holds and rotates the metal material into the absolute perfect angle. Step 3. The robot arm executes the programmed weld path with its servo-driven muscles. And finally, Step 4. The onboard sensors constantly monitor the weld for quality control, ensuring it's completely flawless before moving on to the next one. All right, Section 3. Industrial robot applications. Out on the factory floor. Let's step onto the real-world factory floor for a second to see this in action. In the automotive industry, it is all about high-speed assembly lines, building entire car frames in seconds. In shipbuilding and heavy engineering, robots are managing massive payloads to lay down incredibly thick, continuous welds that a human just simply couldn't sustain. Aerospace relies on them for extreme precision because, a single microscopic flaw up there could be catastrophic. And in general steel fabrication, it's all about achieving consistent, repeatable, flawless quality on every single steel beam. But here's the really fascinating thing. These robots, they don't work in isolation anymore. They're part of the smart factory, which you'll often hear referred to as Industry 4.0. This is the complete integration of physical production with digital technology. We're talking about the Industrial Internet of Things, or IIoT, where machines literally talk directly to each other over a network. We use PLC and SCADA systems, which are essentially the master computers that control and monitor the entire plant, and HMI screens, which are those visual dashboards that allow human operators to oversee the whole complex dance. When you integrate welding robots into a smart factory setup like this, the benefits are just immense. You get unparalleled quality control, massive productivity improvements, and significant energy efficiency, mostly because the robot optimizes every single movement and every single volt of electricity. But we have to be realistic here. There are definitely challenges. The initial setup costs for this kind of technology are substantial. Plus, like any highly complex machine, they're subject to common mechanical and software faults if they aren't properly maintained. Which brings us directly to how we actually keep these operations running smoothly. It's a pretty logical four-step approach. First, operators have to constantly observe for common faults, like wire feeding issues or power fluctuations. Second, they execute targeted troubleshooting tips to address those hiccups. Third, and honestly most importantly, they perform rigorous preventive maintenance. That means cleaning sensors and lubricating joints way before a breakdown ever happens. And fourth, enforcing strict safety precautions. With massive, super fast-moving metal arms swinging around, safety protocols are absolutely non-negotiable. Section 4, Jobs and Career, Your Future in Automation. Because of this massive shift towards automation, the demand for skilled professionals who can actually command these machines is skyrocketing. To build a lucrative career here, you want to start by learning robot programming basics, really getting comfortable with that teach pendant. Next, you develop your technical skills, like actually understanding the metallurgy behind the welds. Mastering this opens up some incredible, high-paying career opportunities as an automation engineer or robot programmer. Just a heads up, if you're heading into this field, definitely prepare for interview questions that test both your mechanical intuition and your software logic. Section 5, Future and Challenges. Next Generation Automation. The future absolutely belongs to AI, machine vision, and advanced smart manufacturing integration. We are rapidly moving away from robots that just blindly follow a pre-programmed path. The robots of tomorrow will literally see the metal right in front of them using machine vision, they'll adapt to slight imperfections in real time, and they'll even adjust their weld parameters on the fly, entirely autonomously. It's a game changer. Section 6, DEVI Automation Solutions, your tech partner. Now, if you are looking to actually be a part of this incredible future, DEVI Automation Solutions is right at the cutting edge of the industry. Their expertise spans across industrial automation, AI and IoT solutions, home automation, and even smart agriculture. Basically, they provide the modern automation solutions, the critical training, and the industrial services that businesses absolutely need to thrive in Industry 4.0. If you found this explainer helpful, please go ahead and like, share, and subscribe. And hey, to consult with their experts or get hands-on training in PLC, SCADA, or AI, you can reach out to them directly at deviautomationsolutions@gmail.com. I want to leave you today with a final provocative thought. As AI and robots fully merge on the factory floor, what role will you choose to play in this next industrial revolution? The tools are out there, the industry is evolving at lightning speed, and the opportunities are truly limitless. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.